Okay. Hello, everyone. Welcome to the January 29th edition of the Carpenter Working Group. It's the 9 a.m., I guess, PST slot. Um, as usual, we'll get started with the Carpenter Working Group blog. If you have any additional community questions that you want to add or discussion you want to add, you can add it into this doc below. I posted in the chat, and we'll discuss them after we get through the project updates. Okay, so to start, I do realize that there's a potentially different set of people that come to this meeting versus the meeting that we typically have in the afternoon. So if I know that there are some people here that also attend the other meeting, so some of these project updates will look quite similar to what we had a week and a half ago. But I'll still go over them again. So right now we're working on getting a release out that has a bunch of features in it. I think the last time we had a release was prior to the break. There's a bunch of work that we've been doing to improve a lot of the disruption behavior. One thing that we've had in the backlog for a while is spot-to-spot consolidation. And so today, there's some concerns you can read about in the design doc around how you might handle spot-to-spot consolidation with respect to all Carpenter really knows about is pricing. And if you just use pricing to try and get the cheapest instance for spot to spot, you're going to trade off availability and you're going to quickly race to the bottom where you just get the cheapest instance, which is most likely not a good instance to have because you'll probably get interrupted quite quickly. So the work was done here. This PR has been merged, and so we're excited to have this feature. This will be enabled with a feature flag, so it will be the spot-to-spot consolidation feature flag. It will be sitting in alpha in the V034 release. But yeah, try it out. Let us know how it goes. We're super excited about this feature. It's pretty much like completing the entire set of consolidation behavior that we've kind of worked on, I guess, and Todd worked on for about a year and a half ago when we first released it. So there's that. Don't know if Nick is here. I don't see Nick here. The other one to call out, because Nick has been working on disruption budgets and just overall improving the disruption performance. We have this introduction of this budgets feature, which basically allows you to, and I'm trying to remember if the API is in here. I don't think it is.
I'm actually here.
Oh,
Yeah,
perfect.
I was hiding. Yeah, so you can basically define a schedule that uses a cron tab or cron schedule that you can define when the schedule starts and when the budget is active, and then a duration of time from every one of the starts for how long it's active. And there's a nodes field that lets you define either percent or a solid amount on how many nodes are allowed to be disrupted. And currently that's all that's in the budgets. I know Bryce has a RFC out right now for defining it by action or method, which is to have separate budgets for either drift or expiration or maybe consolidation or just in general.
Sweet. Yeah. So this will enable everyone to improve the parallelism from one to basically however many they set today. Allow you to scope it to whatever you want.
Yeah.
Okay, sweet. Path to V1, it's another thing we're currently working on. Kind of heading up the effort to get a bucket list of items that we want to release as part of the V1 API within Carpenter. This is obviously the direction we're headed. We graduated the APIs to beta back in November. And so there's a bunch of things that even now we're thinking about doing and some other behavioral changes that we're trying to scope into the V1 release before we say Carpenter is stable. So there's a V1 laundry list that's sitting inside of the Kubernetes 6 Carpenter repo, and then there's also one for the AWS repo. I'm not sure if there's one for the Azure repo. If there was one, you could also throw that in here. But we're taking a look at any suggestions that anyone has around what you would like to see within the V1 API, if any. Yeah, right now we've had some thoughts around potentially creating some neutral labels that are sitting inside of the AWS provider repo that maybe could be more generalized across cloud providers. There's some stuff around our dependencies that we need to kind of clean up and get fixed. There's been some discussion in there's an RFC out right now for like force train behavior, which we're thinking of just calling termination grace period on nodes effectively. So you could define like you know, what's the maximum lifetime of my node? Well, not what's the maximum lifetime of my node, but how long should my node be draining for, so that I don't get like, because right now Carpenter will just like let it hang as long as pods are sitting in a terminating state. And if you have, or if they're having fully blocking PDBs, so if you've got, you know, fully blocking PDBs that sit there forever, Carpenter will never terminate your node unless the instance itself gets reclaimed underneath. So, but that has kind of prompted some discussion about where that termination grace period field should live. And there's been some debate about whether it should live within the disruption block inside of node pool, or whether it should live directly on the node claim itself. And if it lives directly on the node claim, now there's a question about like, where does like expiry live? Is expiry something that is like isolated to a single node claim and not to a grouping mechanism? Because we're kind of thinking of this node claim mechanism as like, I mean, it's like similar to PVC in that it's like a claim on an entity, and maybe it's also the manager of that entity. And can it live on its own? And we've kind of designed it with the idea that it can live on its own. And so does all this behavior that is isolated to a single like entity, can it just like sit inside of that API, and then the node pool wraps that API? So things like drift and consolidation obviously makes sense in like the context of a grouping mechanism, where defining some set of things have to like be, you know, not be underutilized or meet some desired state. But when it comes to expiry and termination behavior, we're thinking maybe that makes sense in the context of the node claim itself. So there's potentially some changes we want to do there as well.
Just add like a little bit of color to what Jonathan's saying. This was like one of the original ideas when we made node claim. One of the original realizations of like what happened when we did node claim was, oh, this doesn't have to be part of an auto scaling workflow. Like it's really just a node on a vendor, very similar to like a CAPI machine. And so we pushed a lot of responsibility into that thing, like basically as much responsibility as we could. And even today with Karpenter, you can stand up like a standalone node claim and just get a node that works. And you could use that for testing. You could use that for a static, you know, a node group style approach. And so I think this is kind of forcing the issue, not forcing the issue, but it's just like another reminder of like, oh, how cool would it be to, you know, have some sort of drain concept for a node that wasn't managed by a node pool, or a standalone node, or, you know, a control plane node, or whatever you could imagine using that primitive for.
Yeah, it starts to look very similar to the like extension style mechanisms you see in Kubernetes, like pods, deployments, stateful sets. You kind of have this core concept, and then you've got other things that can sit on top of it and layer. And that by itself is like, I mean, that by itself is obviously powerful, but it also does create potentially unnecessary levels of abstraction. Potentially, you could argue either way. So there's kind of this inherent trade-off between like additional abstraction versus like the power of the thing living on its own. So that's what we're kind of debating back and forth about. But yeah. Yes, and I think I covered some of the other things. I guess there's some other thoughts around how we want to handle like improvements to our observability in general. So status conditions, we want to add a lot more status conditions throughout Carpenter. For instance, like budgets, for instance, is like one of those things that we need to have a little bit. I mean, there was discussion in the working group last time actually around how we could improve some of the observability around like when my budget is active and which budgets are active and exactly how that looks, because it can look confusing depending on the number of budgets that you have to find in your node pool. And we haven't released the feature yet. We kind of anticipate that is going to be an ask that we're going to get immediately after we do release the feature. So that's another one of those things that we want to make sure we address. And then there's a host of other things. I know that CAPI, for instance, does a pretty good job at propagating a lot of these status conditions onto its resources, and we kind of want the same level of observability, and nodes and other things in Kubernetes in general obviously have pretty good observability that's driven through status conditions. And we kind of think that status conditions itself is a pretty powerful concept. There's this idea that we're trying to kind of propagate that is like, okay, when a status condition changes, can we like fire a metric on that? And can we emit on that for an event, and just like have all of these things that trigger off of a single status condition transition? And so if we can move a lot of our stuff into that, I think we can get a lot of that observability behavior for free. So that's another one of those things that we're trying to make sure we define really well by V1. And then also with that, define the entire, like, this is how you operationalize Carpenter story. So that's that. I brought this up also because Elmiko's here, but I know this discussion is ongoing. Did you want to touch on the Carpenter CAPI working group a little bit?
Yeah, sure, I can. So back, I think before the new year, we started a feature group in the cluster API community to kind of study how we could create a cluster API provider for Capity. And what we're looking at here is, I think one of the things we were studying from the cluster API community is like, do we want to have a way to support kind of like the native Karpenter integrations, like Karpenter provider AWS, Karpenter provider Azure. Did we want to figure out, some way to kind of have those live alongside the cluster API machinery? But it became clear that what the cluster API community would like is they would like to preserve their experience with cluster API, but also be able to use Karpenter. And so one of the integration points we're looking at, and I think this is really interesting given what Ellis was saying before, is kind of this equivalency between a node claim and what cluster API considers to be a machine. So I think right now we're spending a lot of time looking at, is there a way that we could inform Karpenter of what's available through cluster API infrastructure templates, which is what we use as kind of the base types for different instances that can be created. And then could Karpenter return to this cluster API provider a node claim that references one of those infrastructure templates with, perhaps other details as well. So I see double thumbs up from Ellis. So I think we must be going in at least a sane direction. So yeah, that's a lot of the work we're doing now, and hopefully we're just getting to the point where we're going to start a repository in Kubernetes SIGs org for the it'll be Karpenter-provider-cluster-API. So hopefully in the next month or two, we'll get that going, and we'll start to build this integration and see if we can, get it working. So that, I guess that's about it from my side.
Awesome. Thanks for sharing. The next thing to call out, I don't know if David is here. Doesn't look like he is, unless I'm missing him. David is working on some of the docs neutrality stuff that we're trying to push forward in upstream Karpenter. So right now, Karpenter.sh exists as the documentation repo for Karpenter, and it kind of specifically exists for AWS, and some of that, a lot of that is historical, just because AWS is the entity that created Karpenter and donated it to the SIG. There's a issue that is open right now on like where does the documentation live, because right now it sits in the AWS provider repo. And there's a whole discussion that David is kind of driving around this. I know he has some thoughts on it, but one of the spinoffs of that conversation is that there's a docs, like CNCF tech writers office hours, kind of like a docs working group. I believe I think it's this Wednesday at 8 a.m. PST. I think it's listed in here. They're going to be having a discussion. Yeah, it's the 31st. Having a discussion on how exactly this is going to look, or what at least they're thinking about, like back and forth with SIG docs around like what we think might be the right direction here for how we can create like a multi-cloud provider documentation site that has a lot of the core Karpenter concepts inside of it, but also has some differentiation across the different cloud providers that we support. So if you're interested at all, that conversation is going to be happening on Wednesday. And then I'm not sure who added the DRA and Karpenter CAS item.
Yeah, that was me.
Okay, perfect.
Yeah, so I put on here, it's really it's bigger than Karpenter. But so DRA is dynamic resource allocation. It's sort of a new mechanism for a more extensible method for device plugins to register with kubelet. One of the criticisms of the first KEP for DRA was that it sort of made auto scaling impossible, and like almost like auto scaling wasn't really a goal. And then so there was this change to add a separate sort of numeric parameter method for plugins to describe the resources. And there's like a couple of us commenting on that, just for spreading awareness if anyone's interested in this topic. I think there are a few of us that are really trying to push this KEP towards like, hey, numeric parameters need to be the foremost method of having device plugins interact with DRA, not sort of like the optional add-on that device plugins may or may not be able to support, because it's sort of, in my opinion, if it ends up that way, then device plugins will not support it, or at least can optionally choose not to support it, and then those device plugins won't work with auto scaling at all. So it affects Cluster Autoscaler and Karpenter and anything else, custom schedulers, anything that wants to interact with pods and resources. So just letting them be aware of it.
The big problem here, Todd, is an issue with discovery, right?
Yeah, the current draft of DRA has some interaction between the scheduler and the plugin, and then like the device plugins report an opaque set of resources. So then the scheduler has to ask the plugin if the pod can fit. And then so there was an enhancement of saying, well, we can optionally have these numeric parameters, in which case you don't need that sort of interrogation of the scheduler and the plugin. But it's sort of bolted on to the original DRA cap and doesn't replace the opaque parameters. And I think some of us are pushing for, hey, let's go with numeric parameters first, and then maybe someday if you need like opaque things that sort of make cluster auto scaling super hard, like consider that later if there's some use case that does not work with numeric parameters. Or I'm curious, Scott and Miko, if you guys have any thoughts or have looked into this or.
Yeah, I think if not, we can we can keep going. I think we can continue having the discussion. I know there was at least discussion. I know I saw Maciek had chimed in a little bit from Cass' side. Yeah.
All right. Yeah. Just wanted to spread some awareness to people who are interested in auto scaling for it. So thanks.
It's maybe like a CAPI concern as well, insofar as CAPI needs to like make itself aware that a given instance could have a dynamic resource. Maybe like less critical than an autoscaler, but seems like the like discovery feedback loop, like where the information comes from, is like really challenging for any integrators.
Yeah, autoscalers, schedulers, basically anything that's needs to deal with the nodes and what shape they are when they finally go ready, or if pods fit on nodes.
Miko, you have your hand raised.
Yeah, I was just going to say from the CAPI perspective, or from, Cluster API does not, I don't think has a very strong story right now on surfacing this kind of like dynamic information. It looks much more, declarative and static from the perspective of like you kind of set things up and they don't really change. And I think this is something that's probably going to come up in the Cluster API community. I mean, I know I'm going to bring it up, in the next couple of months, which is like we might have to build more in place for there to be a way for, the Cluster API actual like providers to be able to send information back through like conditions or status or whatever, so that you'd have a hope of understanding like something has changed in the underlying like infrastructure or whatever. So I think that's a really difficult problem to solve in Cluster API as well.
All right, yeah, that was it for me. Just wanted to bring it up.
Cool.
Thanks.
Thanks, Todd. That's it for project updates. I don't see any community questions at this point, so I'll also let people continue to add to this doc if they want to. But does anyone have any community questions, just ad hoc?
I've got code questions, but I think I'll follow up in Slack on that.
Yeah, I updated my design by the methods. I think I made it more complicated, but I think it needs to be. So I went further into the reasons. So I think there's room for like including specific drift reasons or specific subcategories of an action. Like I don't think that the specifying drift, for example, gives all the control that you really want. Like I don't really care if something normally drifts versus I might care if something is upgrading the node image or the Kubernetes version, etc. So I wrote more about that in the doc. People can feel free to look at that async, and yeah, we don't have to review it all here. Just figured I'd mention it. Also, I did some annoying metrics PR as well I can share.
I think the image drift is something we've thought about too. Are there other types of drift that you don't want to drift on immediately?
Kate's version drift is one that the Azure provider returns, but I don't. So like essentially my API server is upgraded. Maybe I don't want to immediately roll all the nodes for the Kubernetes version upgrade. Maybe I should though. That's a interesting question. But you want to specify a different amount of nodes as well for the Kubernetes version upgrade versus like a node image. I don't know. But the other ones not so much.
Is that tied to budgets, or is that like definition of drift?
That's
Like, is
just definition of drift, right? So like I return cloud provider drift reason, and that could be like AMI drift or whatever. But I was thinking it might be good to have control over like the disruption windows of like the upgrade lifecycle for different types of upgrade, but it does add a significant amount of complexity. So I would not be opposed to also just saying, let's just keep it at the per method level, like drift itself, etc. But I do think that like standard drift versus upgrade drift is sort of different, right?
Yeah, like if reason is a string and anything can say, you can say budget, reason, any reason right now, like expire, whatever. You could almost, if we didn't pass like is drifted through the cloud provider API and instead relied on the cloud provider to run a controller that labels that acts the other direction, you could essentially have the cloud provider drive arbitrary reasons if you wanted to. So you could say, special Azure drift, and then the customer could define a budget that works with special Azure drift. We talked about this, Jonathan, when we originally did this API of like, should it be the cloud provider control loop, like labeling node claims as drifted, or should it be the Carpenter controller calling the cloud provider? I guess you can expose the information either way, but it's the kind of complexity that until I have like the customer like banging down the door, I probably wouldn't recommend doing it. But it's kind of interesting to see how that might evolve.
Yeah, the reasons are another thing where it's like currently we only really have a need for drift, but if you look at like the methods interface, like it has a type and it could be extended in an easy, pretty way to other reasons as well, other sub reasons. So you have like the top method drift and then like 5 or 6 sub reasons, right? It's the only one that really has a lot of different types besides consolidation, but that's sort of under a different interface. Something to consider, but I'm not sure if there's plans for other methods at the current moment or whatever. So it may just be extra and too much abstraction. Like they say, you shouldn't try to plan for the future. You should wait until you see the need to implement all the abstraction, right? So
yeah, plan for the future, act for the present.
Yeah, exactly.
How do you all orchestrate? So is the Kate's control plane version upgrade not an image upgrade, like a worker image upgrade?
So the Kate's control plane upgrade is like I call AKS RP. AKS RP will change the control plane itself, right? And then it will roll the image or the nodes, right? But you can also I don't know. I'm not as familiar with some of that behavior, but I know it's like you can also control it at the node pool level, so you can upgrade nodes version as well. There's some.
You can like define the Kate's version on the node pool API itself, or like on your, AKS node class API itself, or is that defined only at the RP level, and then you just react to the RP changing?
Let me think about that more. Come back to you. There's some behavior. So Charlie normally handled all the upgrade stuff, and I'm kind of just picking some of it up. He works on like the upgrade sig in AKS, so I'll need to do some more studying to give you a better answer. Like I don't want to like I have like 50% understanding. I don't want to like promise something that isn't the reality. So
I was just curious how similar or different it is from how we orchestrate, because the way that AWS orchestrates is it like it just reacts to the change. So the control plane will change the version, and then we just react to it as to roll the worker nodes, basically.
that makes sense.
I guess there's also a question of like I don't know if we brought this up, but how much does the cloud provider control like when something is drifted? Like specifically for image, like one thing we thought about was like, rather than defining like, I don't want to drift on this condition during this maintenance window, or this like specific reason during this maintenance window, I just say like, the image isn't like usable until a point in time, effectively. So you
Oh,
kind of like, the image is like you have like a testing period for your image, and then like one idea that was floated around that I know Nick has thought about was like min bake time. Do you have like this idea that, and I know that there's like pros cons on either side of like, do you have this thing where you say like the image must sit inside of, you know, I must have the image around for X number of days or X number of hours before I say, okay, this image is like valid and driftable.
so you define that like on the node class, I guess, and then each provider would.
Yeah, it's like a question of like, how generalizable do you want to make it? Like, do you just like let the cloud provider tell you when things are drifted, and then like you just respect that wholly? Or do you have a deep level of control with maintenance window? Like, do you actually need that level of control with maintenance windows? Or is it just like a one-off case of like images or things that are like slightly different, so I need to handle the drift case a little bit different in the cloud provider level? Or are there other, like, I think that's the question I want to answer, just like, is there other utility for like other types of drift control at like the reason level, or is it literally just image, and we can potentially define that through some other abstraction mechanism?
I think that,
Currently,
yeah, there's some different use cases, and I think a lot of them boil down to like trust of like how likely it is for like some particular change to break something somewhere. So like a kernel level change is probably like more likely than like a case patch version change to break something from my point of view. So that's, I guess, like that's how I would see it around like how that would potentially be useful.
yeah, it's interesting.
But that being said, I'm not asking for this level of control either. That's a very nice to have, I think, from my point of view.
Sorry, Alex, you're breaking up a little bit.
Yeah, I think you're trying to attack Alex, but you're super spotty.
Yeah, his internet sometimes is struggling, so turn off the camera, give him more bandwidth, and maybe it'll work.
Kind of.
I could parse "Can you hear me now?" but like only because of the context.
I'll type.
Okay, sounds good.
Cool. We'll wait for, while Alex is typing. Are there any other discussion topics people want to bring up?
I think Ellis mentioned you had a question about termination grace period.
Yeah, if we have time, might be worth getting into. A couple of concerns here. One is I feel really bad that we're thrashing you, and I missed a couple of working groups where we talked about it, and then went and chatted with Jonathan afterwards, and kind of swayed him on a couple of ideas. So
I think it's actually okay. Like the whole like does it live on node pool versus node claim, I think is very trivial. Like that changes very little about the implementation. So I would not worry too much about that. Just wanna,
okay, great.
yeah.
As long as you're feeling not frustrated with the situation, then I'm happy.
Yeah.
I think that we usually try to have concrete use cases before we do anything, as talked about earlier today. But sometimes we have this like saying at Amazon, like looking around corners for customers. And I kind of feel like this is one of those cases where I think there is real like potential power of putting it on the node claim as opposed to on the node pool. You basically don't lose anything if you put it on the node claim, but you do gain potential power and flexibility. I guess the thing that you do lose is there's some complexity for users now needing to reason about fields that can cause a node to shut down. Like previously they were all in the disruption block, and now we've essentially split the disruption block in half. And so one of the conversations Jonathan and I were having was like, during the beta, did we kind of prematurely group these fields together?
Yep.
When they kind of felt like they should belong together, but maybe maybe it would have been better and cleaner just to put them all at the top level.
Yeah, I think if you guys are hoping to support the idea of like independent node claims, then it makes a lot of sense to move those fields onto node claim and be fully supported there. There's an option where you could just do both, or like you can define it on node pool as a mutable version and the node claim, and prefer the node claim that takes precedence if somebody defines it in the template. But I think that's probably going to lead to more hairy confusion about people like being confused over which is the correct way to provide it. So
we have the opportunity. We have one more breaking change in our back pocket right now, which is beta to V1. So we try to, I'm hopeful that we can use that to make sure at least at launch the API feels like it's the best representation of our understanding of the problem space. I don't know, Jonathan, if that means we want to bring into scope like rethinking the disruption block. Like one option would be ship this feature, put it on node template so that we get this like kind of standalone behavior. One wrinkle we should talk about as well is like the drift behavior. And then as like a secondary follow on to the work that you're doing, maybe part of Jonathan's V1 graduation work is to answer the question of, okay, all these disruption block features, like where should consolidation policy live in light of this? Like where should it expire after? I'm pretty sure we need to at some point implement a minimum node lifetime. That's something that users have been begging for in various channels for a long time. But we haven't, so far we've had like other ways to solve the problem. But like min node lifetime and max node lifetime seem like very likely that we'll have them at some point, and also seem like they should live on the node claim itself.
Is that just like we murder the node regardless of what's happening on it? Or what
max
exactly?
node lifetime? Yeah, it's expire after, which is what
That's
Yeah.
actually kind of interesting. Mid node lifetime seems more like a consolidation thing that would be more tied to the node pool, because it's a decision about like how to replace.
Yeah,
or like,
don't murder it yet. Let it live for at least as long, right? So
yeah, which is so like I don't know if mid actually makes sense to put on the node claim itself, but that conversation can happen later, I think.
Yeah, that's actually a good point. And it does start to get a bit weird. The analogy I drew here for Jonathan was like deployment and deployment pod template spec, where
Yep.
you have fields like termination grace period on the pod template, but you have fields like rollout policy on the deployment, and like having the expectation that all the fields nicely live together, like doesn't actually like represent the problem.
Yep.
And so would be max node lifetime, I think is what Ellis means. Yeah, when I was saying that, I meant referring to expiry or expire after.
Yep.
There's also some kind of other things that emerge here around like the never semantic of our nillable duration, like termination grace period never, I guess, like doesn't really make sense. And so
Right.
there was some desire from Jonathan to like retool that semantic as well.
Oh, never is no longer in the implementation plan for that. So that's been gone for a while. Yeah.
So
I think there's a question
it's
about for expiry, because our problem was mainly around like we have this challenge where we're trying to like set the default for everyone in a way that's visible. And so
Yes.
our original goal was like, let's set the default to 720 hours or whatever number of days that is. I forget. It's 30
Yeah.
days. Yeah. But like also we need a way to say like disable this field. And
Correct.
typically disable this field is don't specify, but if you don't specify it and you want to set defaults, you can't do that.
I think the only clear way to do that is to have a second field that enables it or disables it, really. Or you're going to be doing some kind of weird like semantic where negative values are disabled or something like that.
Yeah. This was the fight we had for a while. It was like, do we do -1? Well, -1 doesn't really make sense in duration. So we have to pick this like semantically sounding thing, but isn't familiar to users because it's not like part of the meta v1 duration semantic.
The nice thing is it is familiar to users from like the pod grace period perspective, where like if it's I would say it's familiar to the CAPI users. The way the node drain timeout works is this way. If it's not defined, then it defaults to the most safe behavior, which is don't do the thing. But yeah, I don't. Yeah, I think that this is there is no like clean, easy way out. Yeah.
But maybe just to move the conversation forward, like Jonathan, are you happy to pick up all this ambiguity for V1, decouple it from this effort, and then we can decide to do termination grace period like on the node claim template? Does that seem like a reasonable path forward?
Yeah,
or
I think this is what was
more-
detailed. There's a thread that's detailed in the PR itself. I think that the goal was basically like let's define. I think we're kind of coming to some form of consensus here, but let's define like where we think this should live, and then I think it's fine to like as long as we're all agreed on where it should live like long term past V1, then we can just implement it and do it. And then like you said, like the disruption block, retooling and reshaping that can come as part of the V1 effort, but it'll still, I mean, I think that needs to be clearly defined and designed. I don't want to be like putting it in the disruption block and then, or putting it in the node claim block and then deciding later, actually, we don't want it in the node claim template. And now we have to shift it and everyone is already on this, using this behavior. Like we all want to come to an agreement. So my hope, at least as part of the update I put in the PR was like, can we get the design out for what we think is the right V1 behavior first? Because I don't think it'll take particularly long to get that design out, at least for that portion. And then we can, from that, we can say, okay, we're good to like merge this API and then move forward. Does that make sense, Matt? Like,
Yeah, that
does
seems fine.
Okay.
Yeah, I can flip the two proposals in there so that we document both this and the alternative. It's probably also reasonable to get the expire after onto the, if we want to go down this route, then getting expire after onto the node claim as well in the beta API, so that users have a way to transition cleanly before V1 removes it from like node pool, if that's the way it's going to go down. You can support expire, like you can handle the node claims expire after will take precedence over the node pool if there's a conflict effectively.
My only reservation with that is how do you change the, I guess you don't, like you take the max. Is that how
No, you don't take the max. If the node claim itself has an expire after set, that's the value that's used. Otherwise, if there is no value set, you look at the node pool to see if there's a value set and use that. And if there's not anything, then we do whatever the default behavior is, yeah, as it is current, whatever it currently does. I don't know if that's an optional field or not. So. Cool. Oh, and a quick question about pod deletion. To start the termination process, if the expiration was going to cut it off before it had a chance to do its full grace period. Does using a deletion queue similar to the pod eviction queue that exists for draining today make sense, or should it use something else?
Sorry, I didn't quite follow. You're asking if the existing implementation you're proposing, if it uses the same mechanism that we're using today?
Yes. Should it just use a separate pod deletion queue? Should it reuse the existing eviction queue? And should that be refactored to handle more than just eviction? Or is there some third method of doing this that makes more sense?
Nick, did you have any thoughts?
I could see adding like maybe just adding another parameter into the function of evict just to make it like a force rather than using evict.
It's not a force though. That's kind of the gotcha here, is that we're doing like a standard pod delete as opposed to using the eviction API. So it's like calling completely different.
Yeah, it would be a delete boolean that would just call the delete instead of the evict function, which would be the force here. Yeah, I think maybe having a full different queue would be a little bit too much. Just because I think we really only need one queue for it to be able to know when to evict or delete pods. And if we're doing it serially, then make sure that we're not going a little crazy off the rails with doing too many things at once.
Okay. That's all I got.
Cool. Thanks, Matt, for doing this work.
Yeah.
Anyone else else have, I didn't read through the entire chat. I think that we covered all the discussion topics in the chat from what I can tell. But did anyone else have any other topics they wanted to bring up?
Yes, one quick one for me. I'm sort of thinking the DRA is maybe a candidate for discussing at the Configurator Summit, KubeCon EU. The CFP, I think, closes this Sunday. If we do want to submit it as a topic, I think it's just a Google form that anyone can submit through, but if we think that would be worthwhile as a topic there.
Yeah, I really like that idea. I guess, how does that work, Guy? We'd have to involve, obviously, the DRA contributor that raised the PR, and
I think realistically, yeah. Is that Patrick?
Yeah, SIG batch is pretty involved, so it would be like a SIG batch / SIG auto scaling, SIG scheduling.
Yeah. Once you start digging and going, that's quite a few SIGs. I think there's definitely value in it getting discussed. So yeah, probably worth setting up a DM with Patrick and just figuring out who. Yeah, exactly. That'll be cool.
Yeah, let's follow up offline. I think that's a great idea. Cool. Okay, anything else? Going once. Going twice. All right. Okay, I think that's it. We'll go and wrap it up for today a little bit early. Give everyone 15 minutes back. Thanks everyone for attending. I think there was some good discussion today. So I will see y'all in, I guess, 2.5 weeks at the Thursday iteration of the working group at 2 p.m. PST. Bye, everyone.
Thanks, Jonathan.
Thanks, everyone.
Thanks.
Thanks.
Goodbye.